Good afternoon, and once again welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And we want to conclude handling data 6, specifically looking at the histogram. And in this video, I want us to respond to question number 2 in exam practice, handling data 6. And in this question, we are told that the histogram shows the height of year 7 students. Part A says 5 year 7 students are between 1.4 meters to 1.45. I would want us to go to the histogram and establish that and find out where do we find 1.4 and 1.45, because we are told 5 year 7 students are between 1.4 meters and 1.45 meters tall. Work out the frequency density for that class. Work out the frequency density for that class. We are told that we have 5 students between 1.4, and obviously this has to be 1.45, and we have 5 students there. That means the width times the height is going to give us 5, because this is a histogram. The area of a specific bar gives us the frequency, and that means we have the width 1.45 minus 1.4. Let us get there. 1.45 minus 1.4, which is 0.05 times x, and we know that 0.05 times the frequency density, we should get 5. The height is the frequency density. So in other words, the frequency density is 5 divided by 0.05, which is 5 divided by 0.05, which is 100. So the frequency density for that particular class is 100. And that means we can be able now to calibrate our graph or our histogram. If that is 100, then, and we have how many squares? It's just the same as this. 1, 2, 3, 4, 5. 5 small squares gives us 100. So every 5 gives us 100. So 1, 2, 3, 4, 5. This is 200. 1, 2, 3, 4, 5. 300. 1, 2, 3, 4, 5. 400. 1, 2, 3, 4, 5. This is 500. So this one is already 500, as we can see there. 1, 2, 3, 4, 5. This is 600. 1, 2, 3, 4, 5. 700. 1, 2, 3, 4. 1, 2, 3, 4, 5. 800. 1, 2, 3, 4, 5. 900 and 1, 2, 3, 4, 5. This is 1000. So this is already 1000. As you can see, this is 400. This is 300. This height is 100. So there we are. Okay, let's go to the second question, or part B of the question. Part B of the question is asking us how many year 7 students are there. in total? How many year 7 students are there in total? We have to consult our now calibrated histogram, but of course we have to know this is 1.4, this is 1.45. We have to establish what is this boundary and how many squares are those. These are 1, 2, 3, 4, 5, 6, 7.5. From 1.4 to 1.45 we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12.5 is equivalent to 0.05. What about 7.5 squares, so that we can see what is this equivalent to? It is the same as now 0.05 divided by 12.5. We multiply that by 7.5 and we get 0.03. This is equivalent to 0.03. So 0.03 adding upon 1.45, we get 1.48. This is 1.5, and this is the midpoint between this point and this point, 1.55. And there we are, because we have 1.6 all the way to 1.7. That one is enough now to help us calculate the number of students in year 7, because in the first class we have 5 students. In the second class, we now have to multiply 0.03 times 500. 0.03 times 500. As you can see, the height, the frequency density, which is giving us 15. And for the second one, the difference here, for the third one, the difference here is 0.02 times 1000 times 0.02. We get 20 students there. And then we have 0.05 times 400, 0.05 times 400. Again, we have 20 there. And then we have 0.05 times 300. 0.05 times 300. We have 15 students there. And finally, we have 0.1 times 100, which is basically 10. So the areas of the bars of a histogram will give us the frequency, meaning now the total number of students is the sum of all these, which means 5 plus 15, that is 20, plus 20, 40, plus 20, 60, plus 15, 75, plus 10. Then we have 85. The total number of students, number of students is 85. We have 85 students. Okay, part C of the question, work out an estimate for the median height. An estimate for the median height is, now that we have 85 students, the median is 85 divided by 2, which is 42.5 students. So we need to establish where does the 42.5 students lies. For the first bar, we have 5. For the second bar, we have 15. That is 5 plus 15 is 20. 20 plus 20 is 40. So in this particular bar, we only need 2.5. And that means we have to have the width, which is, we have to have a width that is going to talk about, if we have x there, times 400, it should give us 2.5. In other words, we are now answering part C of the question. And we can easily say 400 multiplied by a width that we don't know, from 1.5 to somewhere here, it should give us 2.5. Therefore, x is 2.5 divided by 400. Let us see that 2.5 divided by 400, and that is 0 0.0. This is 0.0625. So there will be a line there. We are going to have this is 15, 20, 40, and 42.5. There'll be a line there, and this height is going to be 0.00625. So what is the calibration here? It's going to be plus 1.5, giving us 1.50625. This is easily, even if you were to talk about calibration here, this part is 1.50625, or basically 1.51. And that is now the median, meaning that our median is now going to be 1.5. This is median plus 0.00625, which is 1.51. We can say 1.51. That is our median. And that is part C of the question. What about part D? Part D, we are asked to draw a frequency table for the data in the histogram. A frequency table is where we have all the classes and of course the frequencies. And it is easy now that we have had details of different bars. We can already say we have to establish a frequency table. To establish a frequency table, we have to have now all the classes with their frequencies. For example, the class of 1.4 all the way to 1.45, which is this one, we have a frequency of 5 as established there. And then the class of 1.45 to 1.48, which is here, we have a frequency of 15. The third one, we have a frequency of 20. The fourth one, we have a frequency of 20. And the fifth one, we have a frequency of 15. And of course, the last one, we have a frequency of 10. And that is a frequency table, which will help us now solve other questions, part E and part F. This is part D. The frequency table is now as it is shown there. What about part E? Part E, work out an estimate for the mean height from your frequency table. Estimate for the mean height, of course, we need fx column and of course the f column. And now that we have had the groups which are using different limits, we have to establish the class representative, or rather the midpoints of all those groups. And the class rep for the first class is 1.4 plus 1.45. Of course, you divide by 2, which is giving us 1.425. The midpoint is 1.425, the first one. The second one is this plus this, divide by 2. You will verify whether it is 1.465, 1.465. For the other one is 1.49. The other class is 1.525. The fifth class is 1.575, and the last one is 1.65. Those are the class representative. What about the column of fx? It is the x multiplied by the f. For the first class, 1.425 times 5, which is the frequency, you get 7.125. 7.125. For the second class, 15 times 1.465, just find out whether it is 21.975. For the other one, it is 29.8. For the next one is 30.5. For the fifth class, it is 23.625. And finally, we have 16.5. Now we have sigmas. We have to have the summations and the totals of the frequency table. For the sigma, for the frequency, we have 85. And for all this, if you calculate wisely and accurately, you'll realize it is 129.525. And therefore, the mean x bar is sigma fx over sigma f, which is 129.525 all over 85. Let us see that. 129.525 divided by 85, which is 1.524, which is 1.524. And that is the mean of our data. And finally, part F of the question: how many of the students are taller than the mean height? How many of the students are taller than the mean height? The mean height is 1.524. And we have to establish where is 1.524. It is just before 1.55. And what is the difference? 1.55 minus 1.524. And this is 0.026. This is just before 1.55. And what we realize is that it is just here. So this width is 0.026, because as it is, this is the mean, which is 1.524, as it is shown here. From 1.524 to 155, at least to complete that bar, we have a width of 0.026. What about the height times 400? So in this particular region of the remaining bar, we have 0.026 times 400 times 400, so that we can get the frequency. This is obviously 10.4, and then we add every other student who is to the right of that data. So plus 15 plus 10. Reason being, they are all taller than 1.524. And what we have is 10.4 plus 15 plus 10. This is 35.4 students. And because we do not have a 0.4 over students, we can easily talk about 36 students are taller than the mean of that data. Thank you. Let us meet in the next video.